Next, we have Dr. Liron David. Liron will talk about security and privacy of AI and machine learning. Liron David is a postdoctoral researcher at Weizmann Institution of Science and Google researcher. Her research interests include computer security, privacy, and applied cryptography. She holds a PhD and an MSc in electrical engineering. She won the Weizmann Best Paper Prize in 2021 and 2018 and many other awards that will take me 10 minutes to read. So with that, and no further ado.
Okay, hi everyone. Thank you very much. I'm very delighted to be here. So I'm going to talk about security and privacy of AI and machine learning. And so as we all know, artificial intelligence, AI, machine learning, and machine learning are systems which are very truly bringing fiction into reality. They have become intrinsic in our life, from personalized marketing recommendation into some high-stakes fields such as healthcare, finance, and defense. And just like any new technology, with new capabilities, we have new vulnerabilities. So the vulnerabilities can be classified into two categories. One category, the first category is vulnerabilities that enable an attacker to manipulate a machine learning in order to output an incorrect prediction. The other category is vulnerabilities that enable an attacker to extract the sensitive data from the model, whether it is the data itself or the model, the parameter inside, and so on. Okay, so we call the first category, we called it integrity attack, since we attack the integrity of the machine learning. And the second category we called privacy attack, because we attack the privacy of the model, which is the data, which is the model itself. Now, there are many examples for both integrity attacks and privacy attacks. The most common integrity attacks are invasion attacks, data poisoning. And the most common privacy attacks are membership in inference and model extraction. Now, in my talk, I'm going to talk about invasion attacks, which are, as I said, are kind of integrity attacks. Okay, so what is invasion attack? Invasion attack is one of the most common type of AI system. And in an invasion attack, the network is fed with an adversarial example. And adversarial example is an input that an attacker has intentionally designed to cause the model to make a mistake. And now let's see some cool researches and demonstrating evasion attacks and adversarial examples. Okay, so in 2014, a group of researchers from Google and NYU, they found that it's far too easy to fool a neural network with carefully constructed nudge in the input. They actually started with an image of a panda, which neural network correctly recognized as a panda, with 57.7 confidence. And by adding a bit of carefully constructed noise, the same neural network now thinks that this is an image of a gibbon with 90.3% confidence. Okay, so as you can see here on the right, the picture, the image on the right, this is an adversarial example which manipulates the machine learning, and it's classified as a gibbon instead of being classified as a panda. So we successfully manipulated this machine learning, and of course for human cannot tell that there is some noise have been added into this panda at all, because for the human eyes, of course, these pictures are exactly the same. Now, as we can say, adversarial examples actually can be very dangerous, because one paper showed it actually in CV PR in 2018, then demonstrating a various method for constructing stop signs that can fool models by placing various stickers on the stop sign. The perturbations were designed to mimic graffiti, therefore the human would not think it is suspicious. So as we can see on the left image, there is a graffiti which looks very natural, so we did not suspect with anything. And on the right one, there is an image with stickers, which looks very innocent. However, these stickers are actually the physical permutation that applied on this stop sign. And as a result, the machine learning classified this stop with with these stickers as a speed limit of 45 instead of being classified as a stop sign. This is, of course, very dangerous and can have a lot of damage, for example, in autonomous cars. Another interesting work of a paper called Adversarial Patch is a paper that published in NIPS 2017 and demonstrated how a generate of a patch can be placed anywhere within the field of a view of classifier and cause the classifier to output the target class. For example, let's say we have a banana. So the classifier, it classifies it as a banana. But then if we take a carefully constructed adversarial patch and we put it right next to this banana, we actually trick this machine learning, and the machine learning would say this is a toaster instead of classified as a banana. A research group from KU Leuven also showed that adversarial patches can be used to successfully hide a person from a person detector. So as you can see, for example, on the person on the left, he does not hold this adversarial patch. Therefore, the person detector detects this person. On the other hand, the person on the right, he does hold this adversarial patch. Therefore, it is ignored from this person detector. This is, of course, can be dangerous again, because it may enable intruder to sneak around undetected by holding a small cardboard plate in front of their body. So again, these adversarial examples may be dangerous and may be maliciously used. The same experiments, very similar to the previous one, instead of having a patch which is separated from the shirt, here we have a shirt which is together with the patch on the shirt. So if a person wear this t-shirt, which called the sled t-shirt, then he will be ignored and he actually hide himself from the object detector. And so as we can see on the left, on the picture on the left, as long as the person wear this t-shirt, we cannot see this green rectangle, which means that is not detected by the object detector. However, when he hide the adversarial pattern, then he can be detected by the object detector. Okay, so all the example that we've seen here, all these adversarial examples actually show that many modern machine learning algorithms can be broken in surprising ways. And this failure demonstrate that even simple algorithms behave very differently from what they're designed to intend. Now, the question is, do we have good defenses? So the answer is not really, because the adversarial examples are hard to defend against, because it's very difficult to construct theoretical model of adversarial example crafting process. This adversarial example solution, actually solution of optimization problem, which are non-linear and non-convex. And we do not know how to solve this complicated optimization problem. Therefore, we don't have solutions which are theoretical solutions. So do we have an empirical defenses? So the answer is yes, we do. However, they're not perfect. So the most effective defense that we have today is called adversarial training. And adversarial training is a brute force solution where you simply pretended to be an attacker, and then you generate a number of adversarial examples against your own network, and then explicitly train the model not to be fooled by them. Okay, so besides this adversarial training, there are many, many more empirical defenses. However, none of them guarantees a robustness of 100% in all cases. Okay, so what next? Machine learning researchers are highly recommended to get involved in and design methods for preventing adversarial examples in order to close the gap between the designer intent and the algorithms behave. According to Goodfellow, which is one of the pioneers of these fields, many of the most important problems, this is what he said that many of the most important problems still remain open, both in terms of theory and in terms of applications. And on the applied side, no one has yet designed a truly powerful defense again that can resist a wide variety of adversarial examples attack algorithms. Namely, there's still a lot of work that we need to do in order to protect against these adversarial examples. Okay, so if we conclude, of course, AI and machine learning give rise to many, many opportunities. However, it also introduces a new set of security threats, and we need to handle and we need to solve all these vulnerability. And in order to move into the future, it's critical for researchers and for developers and for policymakers to prioritize security when we implement all these AI systems. That's it. Thank you.